Today, I will talk about technology road mapping within the context of the research and application we have been doing in the last 2.5 decades in the Northwest. The agenda I will have will first go through the road mapping framework or frameworks that you could find that we have used as well as we have reviewed, and then the tools that we have used through multiple cases in industry, in the US as well as in other countries. So the roadmap is a tool that was developed according to the literature in Motorola. However, we are very familiar with the companies actually keeping processes secret. And when I was at Intel, again, over about 20 years ago or so, we were using these methodologies as well as other methodologies. One example is you might be familiar with a technology forecasting tool called TRIZ, which was actually initially invented in Russia, and then we learned that it was used by Procter & Gamble for several years or decades before we actually got to know about it in late 90s. So again, this is per literature, it's where Motorola basically started the technology planning with road mapping. Now, literature is plenty on this field, and they all agree that the road mapping helps technology planning and helps you to reach a vision which is based on technology industries. Now, I'm going to go through different frameworks and talk about a little bit more detail. So I collaborate with several colleagues all around the world. One of them is Rob Fall from Cambridge. He is also credited with introducing the road mapping to the academic world and have been a very successful consultant. And they've been working based on this framework here, which is this example. You see a market-driven company where you start by identifying your vision in the market. You look at where you are from a product and technology perspective, and you chart out a path that includes a parallel and integrated product and technology development plan. And it's not just market-driven organizations, it's government organizations who also implemented it and who can implement it. It's just that you need to change basically the nomenclature. So I remember when I left Intel and then came back to academia, the first week I got a call from Naval Power Administration. That's a part of US Department of Energy in our neighborhood in the Northwest. And they wanted to know about technology road mapping, and I gave a lecture, and they criticized me. They said, well, we don't have markets. We get our direction from the Congress, right? And at that time, it dawned on me that they don't really have market drivers. They have basically challenges in their business. And we had to change the market drivers to read the challenges and also the product features to capabilities, because they have a transmission system and power generation system and so on and so forth. Now, my colleagues have basically based their technology road mapping on use of 4 workshops or 4 phases, whichever way you want to call it. You don't always need to have workshops, but which really calls for understanding what your business is all about, and then where markets are going, and then matching that to identify the gaps, and then looking at the same way to the products needed to address those gaps and what your portfolio is, finding again the gaps there, and then going next to the next level, finding technology solutions within or outside the company, and identifying, again, matching them and identifying gaps that will help your R&D, basically, portfolio to start, right? And then you can use, and I'll show you some examples, several different tools to identify these gaps. One of them shown here is called quality function deployment. So it's a very well-known tool from product development. Now, is technology road mapping linear? Now, when you look at the literature, it starts with strategic analysis and then understanding what markets need, matching them with product features that you have, then finding gaps, then finding technologies to address those gaps, then finding technological gaps, and then finally coming up with a roadmap, right? However, it's not that linear. Road mapping is more or less circular and a live process, meaning when you get there to the technology level, because technologies are not linear, they are discontinuous, you will find emerging technologies, disruptive technologies that you haven't thought about in different labs that are basically being developed. So you have to go back and say, does this impact our business? How can we change, or should we change, and modify it? If you don't, you may basically be out of business disrupted by these technologies. I mean, look at the likes of companies that do not exist anymore, that you all know were there 20 years ago, like Blockbuster, like Tower Records. So when you do these plannings and technologies, you need to be thinking about a circular, cyclic process. Now, we have worked with a lot of different companies. I worked with Intel for many years. I'm going to show you the roadmaps that we helped when I was at the university from different companies. I can't show you the roadmaps I've done at Intel for obvious reasons, because they are basically kept secret. Believe it or not, when you leave companies like Intel, you sign a letter saying, I will never share roadmaps, specifically roadmaps. So that's that critical. So we work with an electronics manufacturer in the Northwest area, and they had a different way of adopting the roadmap. They looked at, again, drivers were there, but then they divided their system, which is manufacturing system, into different areas. And then they looked at, okay, where they are, what the driver is, where they should be, and what the technology gap is. This is in one of the areas that they identified gaps, and their final roadmap showing different drivers and technologies that they should invest in. The name of the company was Biotronic. They are the leading pacemaker, I believe, in Europe and here. Now, public roadmaps are available to public, so we can get more into detail. We have worked with several agencies in the Northwest, and one of them was looking at CO2 refrigerant-based heat pump water heaters. And we actually in the Northwest are very keen on energy efficiency. We have met 80% of the demand increase in the last decade or so by energy efficiency. So if you're not familiar with energy efficiency, what it is it's development of a program that may include, for example, lighting or windows, and which requires you to develop measures that can be repeated, and of course, the technologies to be adopted. Now, you have also Costco here, we have back also there. And when you go to Costco, for example, you could buy these light bulbs at half price. The other half is paid by Department of Energy. So, for example, that's an energy efficiency program. So instead of building an additional power plant, in the Northwest, the agencies invest into these programs so that the demand can be dropped down. So again, in this type, we identified the requirements by working with different experts, either residential customers or regional experts, and then identified the weights of these drivers and used the quality function deployment to really assess the existing products. We looked at the adoption of these technology, and this is again a water heater in different countries, from Japan to Australia, what was done, because we're not just looking at what the product features and so on and so forth, but we're also looking at what the regional entities should do so it can be adopted. Because if the technology is not adopted, we won't have the energy efficiency that we're planning, right? That's one of the most important things. And then final roadmap basically showed the drivers and then what the features will be in the future, and then the different enabling efforts. Now, let me switch gears and talk about our story with Honorable Power Administration. So, and the story is the Honorable Power, they started an innovation program about 2004. And that's when we started being impacted by challenges from adopting wind energy in the Northwest and increasing demand. And as a result, the need for technology investments. Now, when you look at this chart, this is a bit dated, but that's R&D investments as a percent of net sales of different industries. So down below, you have semiconductors and science, like software, computer equipment, and so forth. And when you go up, like almost 0% is utilities. So that's where basically their experience were, meaning they had no experience. They didn't know how to select technologies. So they asked me, okay, can you teach us technology roadmap? That's how we started working with them. This is the Office Technology Innovation. And over the years, we have developed a process. So technology road mapping is not a process itself. It's a part of a really a larger framework of managing research and development, right? And then in this case, it was like I mentioned, it's a cyclic process where roadmaps inform the decision makers on the gaps, and then the decision makers then look at the existing portfolio, make decisions on canceling certain projects, which is a big part of managing R&D, that you should not be afraid to cancel and terminate projects. That was a big deal in Japan, that they could not basically get rid of projects, very much emotionally tied, and that didn't help them. So you should be able to what we call terminate R&D projects when basically the project is not no longer helping you. And then that type of termination opens funds, and then the roadmaps help to shape up the calls for proposals, and then the new portfolio is formed, and then again metrics are reviewed, another cycle of roadmap updates happen. Now, one of the results of this was energy efficiency technology roadmap. I mentioned energy efficiency before, and this was this is then cited by United Nations as one of the really useful approaches. And it was in collaboration with different entities in the Northwest. And we used a similar approach like the one that I showed before, the 4 workshop approach, but we deviated a little bit from that. So, and you have to also understand that roadmap doesn't just happen because you bring people into a room. There's a lot of work between these basic workshops. Before these workshops, we had to identify all different plans and business plans and so on and so forth in the Northwest, and come up with a pre-roadmap, if you will, where then we had experts for 2 days for the first workshop, where they basically filtered the roadmaps, the drivers, and then they identified the product and service features that are needed to address those drivers, and then the gaps. Now, they identified 2 types of gaps, and by the way, these people were the leaders in energy efficiency and energy in the 4 or 5 states we have in the Northwest, as well as representatives from DOE, Washington, as well as national labs like PNNL, NREL, LBNL. And after 2 days, we had 2 lists. One is product and service gaps that require technology because it's not delivered, right? There's no technology. Or that is not diffusing, right? The product is there, but nobody's buying it, right? So then we had more or less organized 2 parallel sessions, in which the first one was focused on technology. So we invited professors that are doing research and scientists from national labs and other places to that one. And they worked on, okay, given these gaps, are there any projects going on in any of the universities or national labs? They identified those, and there were some gaps, and those gaps were the ones that was really that was the focus for our road mapping. But the other ones, we were able to identify that there was a program somewhere. The third workshop looked at and focused on marketing experts. We invited marketing experts, and they looked at the market barriers and developed programs to remove those market barriers. And at the end, we had these 2 lists prioritized by a fraction of the group that was in the first workshop, and we had our portfolio. Actually, the portfolio that is going to be funded first, right? So this is an eye chart, but the idea here is to give you an idea that we invited different folks to different workshops, the experts, so that we would really get the information that we needed. And we worked them through a very detailed agenda in which where we basically explain the rules, explain what the process is, and then ask them a specific question that they were addressing on the roadmap, right? Now, there is a difference between a roadmap done by a company versus a public roadmap, because in this case, since this was a government-driven roadmap, many of these experts had used their funds to come, or if they were coming from DOE labs, they had their funds, so it was, in that way, we were able to optimize the funding. But when you do it within a company, you have to work within your organization and use the networks that companies have. So companies such as Intel, IBM, Samsung, they have large networks of university grants, as well as startup companies that they have links to, and they bring those internally, and of course there's a lot of NDAs signed so that nobody hears about them. Now, this is one of the, I think, 95 roadmaps that came out of it, so the product service area and the specific technology, and the format we had here, we focus on the gap and the goal to be met so that the gap can be closed, and technologies needed. The pink ones are not available, the blue ones are available, and then the programs that are going, in yellow, the R&D programs, and then the white are the R&D programs that are needed. Then we just added a summary slide that's just the high priority R&D programs, which technologies they are going to yield, the goals, gaps, and the drivers. Same way with the marketing programs that will help enable the diffusion of the technologies. Then this was published. The key learnings out of this, since we brought all the stakeholders together through these workshops, it was an agreed upon plan. So that was, we didn't have to sell it again, right? And the roadmap, as a result, highlighted the region's priorities. And there were some key takeaways from this. One is bringing everyone together, of course, using professional services. Now, what does that mean? When I, for example, go and try to sell a process to, let's say, in this case, the military, right? Some people might criticize me saying, well, you don't know anything about developing technology in the military, right? That's what they did at Intel or BPA. So we always would work with people who actually delivered that technology in that framework. We would train them first, right? And they would sell the process to the those who would use it. Because when I was at Intel, I didn't need another meeting or another process because I had to deliver this product. There were so many people on my head anyway, right? So it helps to bring credibility to the process, and of course, always a good idea to pilot the process. Now, when you invite these experts, everybody has their own agenda, right? They are experts, but they will try to push things to their way. So make sure to kind of help that, we use third-party judges, if you will. After every workshop, we would go to this group. They would kind of help us if this what they say is really happening. And it is a project, so you have to approach it as from a project management perspective, as a start and deliverables, right? And a strategy consultant. I mean, there should be a program manager and a person who, as well as an expert who knows the process. Now, later on, this was expanded. It's kind of the process was diffusing. If you're familiar, I don't know if you're familiar, but power utilities are working with a consortium called Electric Power Research Institute, EPRI. It's like Sematech of the power sector, and they became a part of it, and then this roadmap became a national energy efficiency roadmap, so we had to, again, hold different workshops for those. And then we got into different areas. For example, we developed a roadmap for transmission technologies, which had different framework, but at the end, again, we start with challenges, and with R&D programs. Now the good thing here is that this is, the tool helps you communicate what you need. So, for example, when an executive looks at this, he or she may not understand how this is helping. Or a scientist looks at this, he or she may not understand how she or he is going to help this. But when we link these, scientists see this, okay, I know how to deliver this. When executives see this, oh, now I see how this basically project is going to help me help my problem. Later on, then, what we did in the BPA was diffused into the whole country. We worked with utilities all around the country to develop a collaborative transmission technology roadmap. We, at this time, really had a focused process which we started repeating, which really focused on having an executive meeting first to help you prioritize, and then specific workshops, a strategic and tactical one to identify the capability gaps, and then later on the technology characteristics and R&D programs. The other thing we have also developed in this realm, what we were calling this organizational chart, is really understand the types of technology roadmaps we had to do. And we call this organizational chart. For example, how was transmission business run? So they had planning and operations, engineering and asset management, cross-functional areas. So that helped us to group the roadmaps, and we kept doing it in other roadmaps. These are the areas that were involved in this roadmap, and these are the kind of pictures from the road mapping sessions where I kind of talk about what it is, who's going to be working on it, and then people work on these roadmaps all day. This was the second workshop. In the first workshop, what they did, we had put them on the maps, printed them, and then they worked on, here for example, these are capability gaps, these are drivers, so they worked on technology characteristics, addressing gaps, and R&D programs. Now, this was another tool that was, I think, very useful. What we did was we made the group to describe, to write an abstract of the R&D program and the research questions, so that when a scientist sees that, it's basically a short proposal that they can expand into. And in that way, we were able to translate the challenge that was defined at the executive level. Now, of course, when you have so many people, it gets messy, okay? So what we did was we initiated, or we called it road mapping police. So we had a team of 10 basically people, every one of us at the table, just monitoring and kindly interfering if somebody is trying to push something, or really strong, opinionated person, so that others can also jump in. Also, when they are not really getting a deeper meaning, they just say improve it, but at what level, right? So that was really helpful. And then for this series, we adopted this nomenclature: drivers, capability gaps, technology characteristics, R&D programs. And that really worked well with other roadmaps in the power sector, where it's really a service sector, not a product-driven sector. This is another example, which again ended up with roadmaps like this one. Now, the process out of this is really was really efficient. The workshops with our tools, these really wall maps and customized post-its, resulting in the final worksheets, and then of course a lot of processing with the third party and my team. We had the roadmaps. Now, you could say, so what, right? So we did these roadmaps, but did it help? It really helped. I mean, but you have to look at it as a whole, meaning the whole R&D program, driven through road mapping. Some of the funded programs actually financed the whole program. One of them was this transmission conductor shunt. It's really a connector, which enabled the BPA to use the existing transmission lines instead of building new ones. There was a direct savings of $34 million. Other project, for example, the EPA joined this effort. There was a bigger effort, which was a 179 million DOE initiative. It was a smart grid in Northwest. That had a basically the indirect impact of $80 million. And I talked about the heat pump related work. This is ductless heat pumps though. And that had a direct saving of $2 million and indirect saving of $15 million in the region. All right. Now, in addition to the work that we did in the region, a lot of my PhD students work on applying these methods, integrating them. So I'll go through them briefly. One of them, Kelly Cowan, looked at how can we also incorporate business models and regulatory structures into road mapping. Because, for example, once you're working on technologies, to help them be adopted, sometimes you need policies, right? So how can you incorporate them? And in this case, he looked at the electric vehicle charges. So he went through the initial analysis of identifying drivers and then coming up with basically roadmaps showing the technologies, the policies that are needed in different forms. And then he created this eye chart, which actually talks about different business models for EV charging and which basically drivers or goals and technologies are relevant for those, so that we had a general roadmap and we could basically specify actions for different business models. Now, here's why though. In the Northwest, I don't know how it is in DC now, but only in Portland, General Electric can sell power. So we don't have, I mean, by law, no one else can sell power. So when you park in a parking lot, you're paying for parking, although you might be charging your electric vehicle, or if you're, again, in your own company's parking lot. So that process is not there. I mean, we don't have a process for companies to get into this business. So this just looked at different business models. Now, another student of mine, this is another work I've been involved with. I teach in Germany, Hamburg, a couple of times a year, teach technology road mapping and technology assessment. And some of them also use those in their thesis work. So one of them used it for Airbus. He works at Airbus. And they're very much easy to apply. And I'm just showing you different applications. They are more or less similar, but different industries. So they went through market and business drivers, product features, gaps, and then picked the product features. And every time he was able to incorporate QFD, so weights were calculated, same with the technologies and resources needed, and coming up with a final roadmap that is linked together. Now, one of my learnings through these is when you try to show this to different stakeholders, make sure that you divide the presentation so that those who are going to be buying it can really understand it. This really shows the linkages so that we can see how things are very much linked, but it's not a good communication tool from that perspective. So you have to be really careful there. Now, so these were some cases. Now, how do we basically bring those roadmaps together? Because all that data comes in, is plugged in, but we need to prioritize, we need to find experts, and you need to forecast technology. So some of those applications. So how do you find experts? Now, finding experts, of course, your companies or organizations and people who work with you, but in addition to that, this is from the lighting roadmap we did. You use who is publishing, who is patenting in this area, okay? What we do, some of my research is mining citations. These are from journal papers, conference papers, as well as patents, okay? Now what we do is, we look at who is citing whom, and put it into a network analysis, and then find who those important people in the center of things, like those who are bridging more people than the others, or who is cited more than the others. So this is just an example. For example, in this case, we were looking at part of lighting, and then when we look at the basic research, the Science Citation Index, certain universities that are very well known as well as labs come out. And then we look at the engineering index. Again, further universities who do more applied research come out. Again, we use different indicators such as number of citations as well as the network indicators. And then what we look at the patents, in this case just the count here, but we also do SNA. We identify this time mostly companies because many of the research in industry, in universities are basically documented through publications, but in the industry it's documented through patents. Although they don't patent everything. A lot of companies who are very secretive. So I was at IBM, the labs up in New York. They showed us, this was back in 2010, the number of patents cited by different companies. Of course, IBM is top number one, right? 4,000 patents in a year. And then Microsoft, about 3,000, Intel, 2,000, Apple, 200. Okay? So that it doesn't, of course, correlate to either the innovativeness or products or revenues. So that tells you about different strategies, right? But it's interesting. I didn't look at from a, if you will, an opportunistic perspective. I was more the scientists here, just identifying who is who and whatnot. But Cree came out, and Cree was at that time an unknown company, a startup, and we're talking about 8 years ago or so. And last year when I was renovating my home, I was buying bulbs at Home Depot. All the LED bulbs were made by Cree. Okay? So you can identify these emergence areas by doing this type of analysis. We did it for a lot of different reasons, for application areas, for Bonneville, for example, when they were doing either finding who is working in this area or what the emerging areas. So these are some examples from refrigeration, just showing you the network analysis. We were going to find the leading experts. And then the next tool I'm going to talk about is technology assessment. Now, let me step back a little and talk about the methodology. So Matt mentioned that we will do a lot of work on multi-criteria decision modeling, and you really need to approach evaluating technologies using multiple perspectives, right? Because you're identifying all these technologies in your road mapping, but you need to prioritize. You don't have all the money in the world, at least not every company. So at PSU with actually Dr. Koglu was my advisor a long time ago. We have worked for decades together. He also was the third editor-in-chief of the transactions. I'm the fifth. So we looked at it from this start for energy, 5 areas: technical, economic, environmental, social, and had a general set of criteria which was specifically applied in different areas. We had more than 10 PhDs coming out of this program, but what it did was it used what we call hierarchical decision modeling, which again, it's very much like any other multi-criteria decision model. We calculate the perspective weights, the criteria weights, and then what we calculate is desirability curves. So the best way to explain this is with burgers. If you're not a meat eater, I'm sorry for that. You could talk about a vegan burger, but if you're hungry, there's a value for a burger. The value of 2 burgers may not be 2 times the value of 1 burger. The value of 10 burgers is definitely not equal to the value, 10 times the value of 1 burger. So, meaning the value goes flat after a while. So similarly, some of the metrics, after one certain level, it doesn't matter if it keeps increasing. We are satisfied at one level. So these value curves help us to identify that. And then we put it all together, come up with technology value. Now, we applied this approach at different levels in different areas. One of them was, again, for our region, looking at energy efficiency programs to prioritize them. Now, remember I mentioned the diffusion and the program. It was very clear in this analysis when we did work through that. And by the way, how do we identify these weights, right? In some cases, they are very much objective, and the value curves, definitely you cannot come up with them. You have to work with experts here too. So on an average, we have 30 to 50 experts we identify depending on the areas we're looking at. For example, here we had experts on energy savings, potential, ancillary benefits, program management, and market dissemination, as well as experts that understand different hierarchies. Executives can give us judgments at this level, engineers can give us judgments at that level, right? So and what they do is they compare items two at a time, but it's a method called pairwise comparisons, and in that way we identify the weights. And of course we use different metrics such as inconsistency analysis, disagreement analysis, and so on and so forth to make sure the model is robust. And this was one of the interesting results here, that the overall savings from an energy efficiency program was as important as the development of measurement and market dissemination. Because if you don't really, if you cannot measure, or if nobody buys it, you won't realize any savings, right? So that this is basically, when you're evaluating technologies, it's not always just technology or technical aspects you have to worry about. All the other aspects make the technology reach to its potential. And then these models also help you to, this is the results of looking at different technologies for the model. So LED lighting for commercial offices came out as a top one. But like I was saying, these models help you to run different scenarios. So you could change the weights at the top level, right? And then see how that changes your model. I'll give you an example. Now, I've seen that change in our area, in the application area of energy. When we worked with BPA, it was mostly during the former administration where environment was prioritized, right? That perspective had a higher weight. And that changed after the elections, and we see that basically the importance of those programs went down. So these models help you to really use that through time. You just adjust what changed at the top level, so priorities. We looked at wind energy. This is actually relevant to the government sector because we work with the state government. We looked at retrospectively though, the adoption of wind energy and what helped it. As a result, we evaluated the policy instruments such as renewable portfolio standards or tax credits, and came up with what we could call policy targets, so which can be used in the future, meaning whatever is important in your region, you could basically adjust the weights, and then figure out what you should include in a policy so that wind, in this case, can be adopted in your region. And these are the results. The top level economic feasibility came out as number one, and then in the these are the top basically criteria. But when we look at the programs, the policies, we saw that there were some equal loading on regulatory items, incentives, and standards, meaning when you want to change basically a fundamental technology, in this case wind, you have to think about regulations, incentives, and standards at the same time. So, for example, today we're talking about electric vehicles, so we need to be thinking through those if you want to change anything. All right, so going fast. Now, so these are all the works of my former PhD students, and both actually, the former one and this one works at different universities. So he looked at biopharmaceutical industry in China. And these were the technologies basically identified by global organizations such as United Nations and whatnot as technologies to invest in. And we looked at what strategy, in this case, China should follow and what resource level they should do. And again, we're working in this case with multinational experts. They're based on their expert. These strategies can be indigenous or imitative, which imitative is the one which they use mostly. And we had some interesting results. These were the technologies at the basic top level, which ones are more really important for them, but this was interesting. So the imitative innovation came out as the preferred one, despite what the government is trying to do there. And the SMEs, so state-owned enterprises came out as the last, not preferred one. The small to medium enterprises came out as the preferred. Now, we also looked at, this was done by NSF funding, NSF centers. So NSF used to be close by here. They have a program called IUCRCs, Industrial University Collaborative Research Centers. They have 64 of them. And they have basically a program. They say, okay, this is our objective. And so we use whatever they have. We work with the director of the program so that we could create metrics and evaluate how these programs are doing. And then these were the criteria, priorities, and these were the metrics, right? Again, we had desirability values, and again, 100 in different metric doesn't mean 100 for the organization like I explained. We measured them, and we had these different centers, okay? And we were able to tell them, for example, one of the centers was at 63%. We tell them what to do. We could tell them what to do using these value curves to improve their score. Now, in addition to technology assessment, technology forecasting is also needed. So, in order to do that, we incorporated, for example, in one case, scenarios into technology roadmapping. And this was, one of my students looked at the deployment of wind energy in Pakistan. And we incorporated different methods. One of them is called fuzzy cognitive maps. It's really another network modeling, showing the relationships of different elements, and you could actually run scenarios to basically, you can activate an item and see how things go along. And that helped us to identify drivers in a more systemic way. And then he developed a similar but different really model. We looked at barriers and then actions items to remove barriers in this case, and came up with roadmaps for different scenarios, actions, and these are the scenarios we came up with. Now, the problem with that, of course, we had to develop a further system of what to start with. When you have multiple scenarios in a roadmap, so which step you go first, right? So we looked at, okay, which are the common steps, and then we could start them and then look around at what was happening and adjust. Meaning, you really need to keep this process alive. You cannot just develop a roadmap or a model, shelve it, and come back in 10 years to see how we did. That should be adopted in a company, in an organization, should be an organic part of it. I mean, for example, companies that I work with, roadmaps are how business are run, right? There's no other documentation. So if your project is not on the roadmap, you're not in existence there. Now, other technology forecasting approaches are what we use a lot of intelligence. In this case, intelligence through publications, right, or patents. So there's another forecasting tool called growth curves. You might know them as S-curves, right? How technologies grow or diffuse. When you don't have enough information about an emerging technology because you don't have data, you can actually use publications and patents to see the activity. So you really need an activity so that you could model and compare things. So we've been using patents or publications to look at and fit them to S-curves for a long time. You could even use litigations, because that is, I mean, in the high-tech area, there's a lot of litigation between companies that shows what's happening in there too. One recent work we did was we looked at spatial basically data, and this was the adoption of solar panels in the Northwest, and we collected that data, correlated with the salary and whatnot, and the region adoption rate to come up with which areas would be ideal to provide incentives so that solar can be adopted. This was done for Energy Trust. Other projects, again, you could use again patents, create some, if you will, indicators that would help you to, if there's a patent increase rate change, it would create an alert that there's some activity that you have to be careful about. So we call that patent alert system for wind turbine technology. Or actually, this is interesting that we could identify some trends in linked technologies so that you could find which one is the slowest, so that you could see how you should be basically helping that so that the whole system can move forward. So in this case, this was for video games, and we apparently that's the latter, or they were adopting technology much slower than the PCs at that time. And reverse selling is actually a military term. It's just to do with the fronts and whoever is at the rear end of the front. All right, now I'm gonna finish my talk very soon, but I want to go to a comprehensive application, how we can kind of bring all these things together. So we work with Electric Power Research Institute, and they were looking at robotic technologies, and they were trying to identify which ones they should invest so that multiple objectives can be met, right? So there are a lot of different technologies, and in the power sector, again, you could use a snake robot for really, like for example, steam generator applications, as well as very basically narrow areas, as well as like nuclear reactors and so on and so forth. Transmission line robot, or concrete crawler for the hydro dams, and again, the submersible robot for dams, right? So we created a model. We looked at, again, they had different perspectives. They had a functionality, design, technological, user experience, electronics. We work with, again, experts all around the world, as well as there, to develop these criteria and then the value curves, and then come up with the technology values as I described in the beginning. And then we started working with those scientists who are working on these technologies so that they would estimate where they would be, different characteristics in different timelines in the future, so that we could create what we call technology development envelope. This was initially developed by one of our students. He's a professor in Thailand now. But in the models, you would see these values. Now, in this one, we were able to basically forecast what they would be if the funds are given at this level. Now, you could also create scenarios and see how that's going to change the values. But this basically is a great tool to help the discussion of executives so that they could decide. For example, when you look at the prior one, you could decide if you're really interested in, for example, transmission line robot, and it has a potential to reach the top value among the others, you could pull it by pushing the investment, right? So you could actually increase the investment, and you could pull in that the technology development. So this gives you a good idea, or gives the executives a good planning realm. All right, so with that, I think we can conclude that road mapping is really an effective tool for managing technology, because it covers from planning into portfolio management, as well as it needs to be complemented by assessment and forecasting tools so that you could prioritize. And I also have to add that it's a live process, so we need to adopt it and keep using it. So with that, I'd like to thank you for listening, and thank you for having me over here.